Say hi, everyone. Welcome. Today we're hosting Matthew Jiwa. Matthew is a PhD candidate at the University of Melbourne. He's studying the contextual factors and characteristics of information that drive us to seek it. And he is tuning in from all the way from Melbourne right now. So that's where we are to you. Yeah, I think I'll hand it over for you, and you can.
What's in the chat? Sorry, I just want to make sure there's nothing.
Yeah.
All right. I'm monitoring it down here, so the chat.
So if anyone, again, you can let us know if there's some admiration going on. Over to you, Matthew.
Cool, thank you very much. Let me just share my screen here. Let's see. Cool, is that sharing okay?
Yes.
Yes.
Cool. All right, well, yeah, thank you for having me. Today I'll be presenting on the characteristics and contexts that drive curiosity. I do have numbers on the slide, so if you have a question, you want to keep track of the slide number that it relates to. Otherwise, I'm happy for you to interrupt throughout and get me to clarify something if something's unclear. All right, so yeah, this is a talk about information and information seeking, but I actually want to work backwards in a sense and start off by talking more about beliefs, and in particular, polarized beliefs. So to illustrate this, we'll be looking at beliefs about the likely outcome of the 2020 US presidential election about 2 weeks prior to its occurrence. So firstly, beliefs amongst Democratic supporters, so those who supported Joe Biden. And the general consensus here was that Joe Biden was the likely winner with sort of varying degrees of confidence, but the overall consensus is quite clear. But then when we look at Republican supporters, so those who wanted Donald Trump to win, we see that Donald Trump is seen as the likely winner. Again, with varying degrees of confidence, but with as many as 23% believing that that outcome was all but assured. Now, when we look at these two distributions of beliefs, they almost couldn't be more different, right? These are two groups that are effectively living in different epistemic realities. And these polarized beliefs are far from harmless. They can lead to distrust in the democratic process and to a lack of consensus on how to tackle existential issues like climate change. So it's important that we understand how these sorts of belief structures arise, what differences exist between these groups that lead them to form such polarized beliefs. And one key determinant is, of course, media consumption. So in the US, if you're left-leaning or moderate, then you're likely to rely on sources like these for your news, which tend to be broadly positive about Democratic Party candidates like Joe Biden. Whereas if you're right-wing and Republican, you're more likely to rely on sources like these for your news, which tend to favor Republican Party candidates like Donald Trump. Now, when we look at these example articles, it becomes quite clear how these separated media diets could potentially lead to polarized beliefs. Now, this tendency to favor congenial news sources is something that's well established, but it does often lead us to form biased or inaccurate beliefs, which leads us to sort of wonder, well, why do we engage in this behavior? And there are a couple of key candidate explanations for this that I want to outline. The first being that this is entirely rational Bayesian behavior. So just to illustrate this, those supporting Joe Biden might have prior beliefs that frame him as a more competent or more likable candidate, and therefore he's more likely to succeed. And as a consequence, news sources that report favorably on Biden would be seen as more accurate, more aligned with the truth. So we'd sample from those more frequently. Alternatively, I could argue that if you want Biden to win, then news about his successes might evoke positive affective states. And the desire to achieve these positive affective states would also lead you to favor sources that report on him from a positive angle. Now, these two explanations are not mutually exclusive by any means, but the individual contributions of each can be quite hard to examine because they effectively predict the same patterns of behavior. So in the first study I'll be talking about, we really wanted to focus in on this idea of informational hedonism. We wanted to ask, well, to what extent does this actually influence information selection? What are the mechanisms that underlie this, and what are the consequences of engaging in this type of behavior? So in experiment 1, we had subjects participate in a series of lotteries in which they could either win and get 20 cents, or they could lose and get nothing. However, on each of these lotteries, they weren't actually shown the outcome. What they were shown instead was a prediction of the outcome made by one of 2 available what we called psychics. So for each of their lotteries, they could choose which of 2 available psychics' predictions they would like to see. And to help them decide which psychic's prediction to view, they were first shown a series of example predictions made by both of the psychics. So during these example predictions, the 2 psychics would both predict the outcome of some irrelevant lottery where nothing was at stake, and then the true outcome of that lottery would be revealed. And there were 5 of these per trial. So a couple of key factors varied between the 2 psychics. Firstly, they would vary in how accurate they were, so how often they correctly predict the true outcome of this example lottery. And secondly, they would vary in how positive they were, so how often they would predict win outcomes relative to losses. So after being shown these 5 example predictions where the psychics would vary on those dimensions, we asked them, well, whose prediction would you like to see for your own lottery where there will be 20 cents at stake? Their chosen psychic would then predict the outcome of their lottery, and the true outcome was not shown. So this was the only information they received about whether or not they had won 20 cents. One important factor here was that psychics that were more biased towards making positive example predictions, so psychics that regularly predicted wins during the 5 example lotteries, were also more likely to predict a win for the participant's own lottery, which is not something we told them explicitly, but was sort of built into the design to mimic the sort of, I guess, journalistic consistency that we might expect, the tonal consistency that we might expect to see in the real world from a real information source. So all of this on screen constitutes a single trial, after which we told them, well, a new set of psychics will be brought in, and you should observe their example predictions and make a fresh decision because they're independent of these ones. And we had 4 blocks of 16 trials each. And at the end of each block, we asked participants to estimate how often they thought they had won during that block. So how many of the 16 lotteries they thought they had won, and also to provide a confidence rating for that estimate. Are there any questions about the paradigm before I get into the results?
Yeah, it's very interesting, but there's no, like from the participant's point of view, there is no accuracy incentive, is there? I mean, all they're picking is the psychic. That's it, right?
Sure, so there's no instrumental value, but the psychics could vary in how accurate they were. So they could see a psychic correctly predict 4 out of 5 example lotteries correctly and think, well, whatever they tell me is probably true. Or they could see one predict 3 out of 5 correctly and think, well, they might not be quite accurate on my lottery prediction.
Okay, so the rational thing to do is always to pick the psychic who was more accurate during the training session. If
you want to know accurately how often you're winning on your own lotteries, then yes, absolutely. You should be picking the one that's most accurate.
Okay.
But of course, there is no instrumental value. So if you pick the one that's less accurate, it's not like you're losing money, but you just won't have an accurate understanding of how often you're winning.
Okay.
All right, so getting into the results, the first thing we wanted to ask was, okay, if the 2 psychics were equally accurate during their example lotteries, but one of the psychics predicted wins with a higher frequency than the other psychic, are we indifferent to that change, or do we see them as totally equivalent? And what we found on average was that participants tended to prefer the psychic that predicted wins with a higher frequency. So here we have the proportion of trials where the more optimistic psychic was chosen, so the one that predicted more wins, and this was significantly above chance level. And when we then look at the trials where the 2 psychics were not equally accurate, so one of them was more accurate than the other, we see something quite similar. So on the y-axis here, we have the probability of choosing the more accurate psychic. And all I've done is divided this up by trials where the more accurate psychic predicted fewer win outcomes than the less accurate psychic on the left. So it was a more pessimistic psychic, but more accurate. And on the right, we have trials where the more accurate psychic also predicted more win outcomes than the less accurate psychic. So on the right, trials where the more accurate psychic was also more optimistic, more positive. And what we see is that accuracy seems to be important across the board, regardless of how positive the psychic was. They were preferring the more accurate psychic at above chance level. But what we do see is that when the more accurate psychic was also more positive, we then see that the psychic is being chosen with a higher frequency than when the more accurate psychic was less positive than the less accurate psychic.
Matthew, are you monitoring the chat, or shall I?
Is there a, just check the chat. Could they predict a psychic that is terrible and just predict the opposite? We did think about this. So the psychics were always accurate on at least 3 of the 5 examples. Therefore, they couldn't view one that was, say, correct on 1 out of 5 and think that whatever they predict, I'll just reverse that in my head. So a good question, and we did think about that. Yeah. Cool. All right, so in order to better understand participants' choice behavior, we constructed a series of computational models. Now, these models just varied in whether the accuracy or the positivity of psychics' example predictions were used to predict choice behavior. So for example, according to the accuracy-only model, the participant would watch the 5 example lotteries, and they would keep a mental note of how often each psychic was correctly predicting the true outcome. And then based on that information, they would then make their choice about whose prediction to view. Whereas according to the positivity-only model, participants would be watching those 5 examples and just keeping track of who predicts wins more often. So who predicts wins with a higher frequency, and then basing their decision on that information. Of course, the accuracy and positivity model would operationalize the hypothesis that participants watch those 5 examples and keep track of both how accurate and how positive each psychic is, and then make their decision based on the combination of those 2 factors. And then finally, we had the accuracy and positivity tiebreak model. Within this model, only accuracy was a determining factor, but if the 2 psychics were equally accurate, then positivity was introduced into the model as a sort of tiebreak criterion. So this would fit a participant who chose the more accurate psychic, but when they were equally accurate, they preferred the more positive one. So we fit all 4 of these using a hierarchical Bayesian modeling procedure, and then compared them using approximated k-fold leave one out cross-validation, where each fold was a single participant's data. So looking at the model fit statistics, it's the model that included both accuracy and positivity as parameters that seems to provide the best fit to the data. However, when we look at this at a subject-specific level, we actually find that this is being driven by a subset of participants. About 45% of participants are best fit by the accuracy-only model, the most rational behavior, as you would expect, whereas about 30% are best fit by the accuracy and positivity model. And we can sort of see how these different groups of participants cluster together. So here on the x-axis, we have the accuracy parameter from this accuracy and positivity model. So this is how much they cared about how accurate the psychic was in those example predictions. And on the y-axis, we have the positivity parameter, so how much they cared about how positive the psychic's example predictions were when choosing between them. So for example, participants who were best fit by the accuracy-only model, these blue dots here, tended to have a high accuracy parameter and a low positivity parameter, and sort of so on for the other groups. All right, so that's a little bit about their choice behavior. The next question we wanted to ask was, so how does this biased information seeking that we're seeing affect the beliefs that the participants form about the world state? So just to remind you of the paradigm, at the end of each block, we ask participants, well, how many of those trials do you think you won out of the 16 trials you just did? And how confident are you in your beliefs about that? So when I talk about beliefs, those are the outcome measures that I'm referring to. The first thing we need to consider, though, is the effect of biased information seeking on the information that we view. Now, as I alluded to when explaining the paradigm, psychics that were more biased towards positive example predictions were also more likely to make positive predictions for the participant's own lottery. So it makes perfect sense that participants that preferred positively biased psychics were showed a greater number of win predictions by their chosen psychic. So up here, this is just the number of wins predicted by the participant's chosen psychic on that block of 16 trials. And this is a positive association that was built in to the experiment. So this is more of a sanity check than anything. What's more interesting, though, is that participants then used that biased information to inform their beliefs about the world, such that those exposed to positively biased information tended to form positively biased beliefs. They thought they were winning more often. So here, this red outcome is the number of wins that the participant estimated that they achieved at the end of the block. Okay, so one question that remains, though, is, are participants at least aware of the bias in the information that they're consuming? And they might say, well, this is my best guess for the number of wins I achieved based on the information that I received. But of course, that information wasn't as accurate as it might have been. I did choose psychics that were less accurate than some of the others. So maybe I should hold those beliefs, but hold them with slightly lower confidence than I might otherwise. So if we include confidence in their beliefs as an additional outcome variable, we can actually test this question. And what we find is that participants who chose to view positively biased psychics, who were shown positively biased information and formed positively biased beliefs, did not have lower confidence in those beliefs. In fact, if anything, they tended to have higher confidence in the beliefs that they had formed. So just to quickly summarize those results, we observed biased information seeking of some description in about 55% of our participants. Those who sought biased information tended to then form a biased view of the world, and those views were not tempered by a decrease in confidence about those beliefs. However, based on these findings alone, we can't determine whether participants chose to view predictions from positively biased psychics because they wanted to be shown positive predictions about their own lotteries, or because they perceived biased psychics as being somehow more trustworthy. Now, either of these could account for the results that we observed, and there are theoretical reasons why either of them could also be true, and I'll talk you through those in the next couple of slides. So let's start off with the informational hedonism assumption. This is the assumption that we're choosing to view from information from biased psychics because we want to be shown positive predictions about our own lotteries because it evokes some positive affective state, presumably. Now, this would explain why we chose to view predictions from biased psychics, but it wouldn't necessarily account for the differences in confidence that we observed in our sample. However, those could be explained by a parallel phenomenon, something like asymmetrical belief updating. Now, this is just the phenomenon by which we update our beliefs more following positive information than we do for equivalent negative information, which would mean within this paradigm, at least, that when we're shown a win prediction for our own lottery, we believe that prediction more. So we have a larger update in our beliefs. And these bigger belief updates would equate to greater certainty, leading to those higher confidence ratings. So the combination of these two effects could technically account for the results that we observed. Now, alternatively, it could also be the case that we attend to or weight predictions differently depending on their valence. So, for example, accurately predicting good outcomes could be seen as more important for the source's credibility than accurately predicting negative ones. Or alternatively, incorrectly predicting negative outcomes could be seen as more detrimental for the source's credibility than incorrectly predicting positive ones. Now, if this was the case, then this would lead us to perceive positively biased psychics as more accurate or more credible, which would explain both the information-seeking effect and the confidence effects that we observed. So in order to differentiate between these two explanations, we conducted a follow-up study in which we asked, do participants see positively biased predictors as more credible? So again, we had a similar paradigm. This time we only showed participants one psychic at a time. We showed the participants, again, 5 example lotteries, and the psychic would again vary in how accurate and how positive those example predictions were. This time, of course, there was no choice phase because there's no psychics to choose between. That same psychic would then immediately go on to predict the outcome of the participants' lottery, again, with the true outcome not being shown. One important difference in this version, however, is that on the participants' lottery, regardless of how biased the psychic was during the examples towards predicting a win or a loss or whatever, on the participants' lottery, they would predict winning and losing outcomes with equal probability. So here the goal was to decouple biased psychics from positive information, which allows us to test that prediction. After the psychic predicted the participants' lottery, we then asked them, well, okay, this psychic predicted that you lost, for example, on your lottery. Now, what do you think the outcome of the lottery was? And they could respond on a continuous scale from 0 being definitely lost to 100 being definitely won. All right, so for the analyses for this study, we quantified this in terms of what we're calling belief updates. So I'm just going to explain what I mean by that before we look at the results. So let's say, for example, this psychic predicted that you lost your lottery, and you thought, well, they were quite accurate during the example lotteries. They're probably correct. Maybe not 100% certain, but you might respond with something around this on the scale, towards the definitely lost part of the scale, but not quite all the way there. Now, when we're quantifying this in terms of a belief update, we would quantify this as a belief update of 40 points, because it is 40 points from the point of indifference being the midpoint of the scale. And it's positive because it's in the direction of the psychic's prediction. You're agreeing with the psychic. So if, for example, you thought, well, this psychic's probably wrong, I don't think I agree with the prediction, you might respond in the opposite direction. And in this case, we would be quantifying this rating as a belief update of -10 points. If this doesn't immediately make perfect sense, all you really need to understand is that this is our way of quantifying how much you believe in this psychic's prediction, with a greater positive number being you trust the psychic more. All right, so looking at the results, the first thing we can look at is, well, did the participants trust psychics that were more accurate more? And we see that on average, the belief update is larger for the high accuracy psychics than it is for low accuracy psychics, which is what we would expect. It's more of a sanity check than anything, but it's nice to see that it's there. What's slightly more interesting is that we see larger belief updates when the psychic predicts a win on the participants' lottery, that's the green line here, than when the psychic predicts that you lost on your lottery, and that's the red line here. Now, this relates to the idea of asymmetrical belief updating that we talked about a little bit earlier. So again, it's not particularly unexpected to see this here. So in order to test the main question that we're interested in, which is, are positively biased predictors seen as more credible? What we can do is we can examine belief updates between more positive and more negative psychics. So here, this is just a plot of the mean belief updates split by how positive the psychic was in their example predictions. So during those 5 example lotteries. Now, this is just a median split by positivity. So on the left, we have psychics whose example predictions included more losses than wins. So they tended to predict losses more often. And on the right, we have psychics whose example predictions included more wins than losses. So these are the more positive psychics. Now, these look pretty much identical, but of course, there's still work to be done to establish that they definitely aren't meaningfully different. So to achieve that, we constructed another computational model. This time we're predicting the belief update on a trial-by-trial basis from a constant or baseline level of belief update that was subject-specific, plus an accuracy parameter multiplied by the number of correct example predictions the psychic made, plus a positivity parameter multiplied by the number of positive predictions, positive example predictions the psychic made. And then we multiplied all of this by a symmetry parameter to allow the belief updates to differ based on whether the psychic predicted a win or a loss on the participant's own lottery, that final prediction. We also constructed a model that was identical but didn't include this positivity parameter. So within this model, only the accuracy of the psychic's example predictions and the valence of the final prediction, so whether they predicted a win or a loss on your lottery, dictated the predicted belief update. Looking at the model fit statistics, we find that the model that didn't include the positivity parameter provided the best fit. So including this extra additional parameter didn't improve the fit of the model, suggesting that participants didn't consider the positivity of psychics when evaluating their credibility. And just to affirm this a little bit further, we can examine the posterior distribution of the hyperparameter that governs the mean of the positivity parameter across all participants. So here, this red shaded region is the region of practical equivalence. All this means is that parameter values within this region can be treated as not meaningfully different from 0. So as the entire posterior distribution lies within this region, we can conclude that this parameter is effectively equal to 0. And I also plotted the individual level point estimates for the positivity parameter and found that they also all lie within this region. So we conclude based on this that positively biased predictors were not seen as more credible. So what does this mean? Well, biased psychics were not seen as more credible, which means that the biased information seeking we observed in study 1 is better explained by the hedonic tendencies explanation than it is by the biased beliefs explanation. All right, so just to wrap up this first study, let's bring this back to the framework that we started out with and talk a bit about where this leaves this particular line of research. So based on the present findings, we conclude that congeniality bias, that is the tendency to prefer information sources that affirm our existing beliefs, is at least partially attributable to hedonic preferences. However, the relative magnitude of this contribution compared with other factors such as Bayesian rationalism is something that we can't comment on based on these data. Nor can we comment on the individual variability in the relative contributions of these factors to congeniality bias. So if we are to design interventions to combat polarization, then gaining a better understanding not only of which of these behaviors is most prominent, but also of how their prominence differs by things like demographics, such as age, gender, education, cognitive or personality traits like need for cognition and openness, and of course, political leaning as well. These could all help us inform more targeted interventions to combat polarization. Just as a final note on a different aspect of the data, we also found that beliefs formed on the basis of biased information were held in quite high confidence. Now, previous research has shown that those with the most extreme beliefs tend to have the highest confidence in their beliefs, and the current findings do present a potential mechanism to explain this phenomenon, although much more work would be required to affirm this. All right. That brings me to the end of the sort of first section of this talk. So that's a bit about how we choose where to get our information from. In the next section, I'll be talking a bit more about how the information we receive relates to the decisions that we make. Because of course, a key role of curiosity is to inform our decisions. We gather information from our environment and we use that information to maximize the rewards that we gain. One thing that varies, though, is the relative quality of this information. And at least from a Bayesian perspective, what we should be doing is weighting that information by its relative reliability. So let's take an example. We'll be looking at some information and deciding whether or not an election was legitimate. So let's say we're scrolling a news feed and the first thing we see is this. This is a press release from the Department of Homeland Security, which we see as a probably quite accurate source. So we would ascribe this quite a high predictive validity. Let's say this is 90% accurate, and it's saying that the election was legitimate. The next thing we see is a tweet from a satirical news outlet that's just making fun of the situation. This would indicate, if it were true, that this was an illegitimate election, but of course this tweet is not based on any factual information. It doesn't tell us anything, so we can assume that this is effectively 50% reliable. It has no real predictive value at all. And finally, we come across a tweet that has been explicitly flagged as being misleading. So based on the presence of this warning message, we can assume that the contents of this tweet actually have negative predictive validity. It's about a 10% chance of being correct, and let's say a 90% chance of being incorrect. That's just an arbitrary number, but let's take that as an example. Now, in theory, what we do is we integrate all of this information and we evaluate the likelihood of each of our candidate hypotheses using Bayes' theorem, something like that. And we arrive at some percentage probability of each of our hypotheses being accurate based on the information that we viewed. I say this is what happens in theory because in reality, we're actually not all that great at doing this. Instead, studies have shown that we often fail to ignore information, even when we've been explicitly told that it is entirely unreliable, which can lead to a bias in beliefs and decisions towards predictions made by fully unreliable sources. And similarly, studies have demonstrated that we aren't as successful at integrating reliably incorrect information into our decisions, leading to greater noise and less accurate decisions. However, one question this throws up as a curiosity researcher is, well, how much does this actually matter? Because in the real world, if we're not satisfied with the information that we have, if we're not confident that we can make an accurate decision on the basis of what we know, we can just kind of sample some more information until we reach a point where we are satisfied that we can make an accurate decision. So what I guess I'm asking is, do we, through our information-seeking behavior, compensate for these cognitive biases or shortcomings? So in order to test this, we constructed a paradigm that looked a bit like this. Now here, at the end of each trial, we would be asking a participant to choose between two options. Here we have an orange option and a pink option, and one of these will win the lottery and one of them will lose. To help them choose which color to pick, we first showed them a series of low reliability information sources. So here, for example, we have a source that is predicting that pink will win the lottery, but it's only 52% reliable. So it only has a 52% chance of being accurate. Now, across the trials, the cumulative difference in the reliability of the predictors favoring each color would vary. It would vary between either 0, 2, 4, or 6%. So here, the cumulative reliability of the sources favoring orange is 2% higher than the cumulative reliability of the sources favoring pink. So the overall consensus here is suggesting that orange is slightly more likely to win. We would call orange here the dominant color, as I'll be referring to it in the future, as it has the higher average reliability of sources predicting it to win. So after seeing these 6 sources of information, we told participants, well, we'll allow you to see one more information source if you would like. But in order to view that, you'll have to complete a BDM auction. So within this auction, the participant would make a bid between 0 and 5 cents. And then in the meantime, the computer sets a secret price between 1 and 5 cents. So if the participant's bid is equal to or higher than the price set by the computer, then they will pay that price and they'll be shown that extra information. And if their bid is lower, then they will pay nothing, but they won't be shown that information. They'll be shown a blank screen for the equivalent time instead. So if the participant bids 2 cents and the price set by the computer is 1 cent, then the participant will pay 1 cent and be shown the information. But if they bid 2 cents and the secret random price happened to be 3 cents, then they would pay nothing, but be shown a blank screen instead. So all this really means is the higher they bid, the more they're willing to pay, the more they want to see that extra piece of information to help inform their decision. So after they complete this BDM auction and they're either shown the information or not, we ask them to choose which of the 2 colors they think will win the lottery. And we tell them if they correctly predict which will win, then they'll be rewarded with 15 cents. So this was the control condition. We also constructed what we're calling the inverted condition. Within this condition, one of the sources was inverted so that it was now reliably incorrect. So you'll see I've highlighted it here with a dotted line. This source previously in the control condition was predicting that orange would be the winning color, and it had a 55% chance of being accurate. And it's now predicting that pink will be the winning color, and it's only 45% accurate. So this is communicating the exact same information because this is a binary lottery. So here the information content is actually exactly the same. A Bayesian rational observer should not change their behavior between those two. But of course, we know that in previous studies, at least, this type of reliably incorrect information has induced greater variability in responding, leading to noisier responses. Finally, we constructed a third condition that we're calling the unreliable condition. This was exactly the same as the control condition. However, in this condition, we added on a 50% accurate source to the end of every trial. So this is a 7th piece of information that was shown at the end of each sequence that was always 50% reliable. Now, this extra source could either affirm the consensus of the other sources by predicting that the dominant color would win, as it does in this example here, predicting orange to win. Or it could challenge that consensus by predicting the non-dominant color to win. So if this source was predicting pink instead, then it would be challenging that consensus. Now, again, a rational observer should just ignore this information because it is 50% reliable and it has no bearing on which outcome is more likely. But previous research has suggested that this won't necessarily be the case. However, when we looked at our data, we actually found that in the unreliable condition, choice behavior was not influenced by the color predicted by this fully unreliable 7th source. So here on the right, we have the probability of choosing, on the y-axis, we have the probability of choosing the dominant color, making the correct choice. And on the right, we have trials where the fully unreliable source also predicted the dominant color to win. And on the left, we have trials where the fully unreliable source predicted that the non-dominant color would win. Now, based on previous findings, we would expect to see greater accuracy when the dominant color was also supported by this fully unreliable source, and lower accuracy when the fully unreliable source was challenging the consensus, predicting the non-dominant color instead. But here we see no such effect, which suggests that participants were actually pretty good at ignoring this fully unreliable information when it was clearly flagged to them that it was only 50% reliable. Interestingly, though, when we look at the accuracy of choice behavior between the conditions, we find that overall choice accuracy, this is how often they correctly choose the dominant color, was actually highest in the control condition compared to our experimental conditions. Now, if you're following from what I've said previously, this is expected, at least for the inverted condition, whereby based on previous findings, we see that inverted or fully unreliable, reliably incorrect information tends to be harder to integrate into a decision process. But it is interesting that we see this effect, including even in the unreliable condition, despite the fact that they seem to be pretty good at ignoring this fully unreliable information. So this suggests that somehow the process of ignoring this unreliable information, even though they're successful in doing that, they've been told this is unreliable and they've correctly not included it in their decision process. It seems that the process of actually doing that has seemingly made their decisions less accurate, perhaps by inducing a cognitive load, making responses slightly noisier. All right, so that's a little look at the choice behavior between conditions. I want to now turn our attention to participants' bid sizing. So just bearing in mind that larger bids mean they're more interested in seeing that extra piece of information, getting one more piece of information on which they can base their decision. Now, intuitively, what we see is that participants tend to bid more when the difference between the two colors was lower. So for example, when the cumulative reliability of the sources favoring orange was exactly the same as the cumulative reliability of the sources favoring pink, that's the 0% condition, that's when participants were most interested in seeing a bit more information. And we see this decrease as the strength of the evidence favoring one color over the other also increases. However, what we do find is that participants seem to bid more in the control condition than they did in either of our experimental conditions. And we confirmed this using a Bayesian ordinal regression approach that I won't dwell on the details of too much. But we confirmed using this approach that there were both main effects of percentage difference and of condition as well. Now, this is a pretty counterintuitive finding, given that participants were less accurate in the experimental conditions. We would expect them to be more interested in acquiring a bit more information in those circumstances, but we instead find that the opposite is true. Even though they don't have very accurate beliefs, they're not as interested in acquiring a bit more information. So let's quickly summarize this and talk a bit about where this leaves us. So we find that choice accuracy was lower in the presence of unreliable and reliably incorrect information. Now, I've highlighted presence of here because the actual contents of those information signals wasn't particularly impactful. It was more so whether they were present in the information environment. And we also found that these inaccuracies and beliefs were not counterbalanced by an upregulation of information seeking. And in fact, information seeking was instead reduced in these conditions. So why might that be? Well, one explanation might be that these types of information tended to induce a sense of overconfidence in one's understanding of the probabilities at play. So for example, reliably incorrect information could be treated as more deterministic than reliably correct information. So for example, seeing a source predict 45% for orange could be seen as more damning for orange than seeing a source that is 55% accurate predicting pink is seen as positive for pink, which would lead to greater confidence and therefore less interest in that extra information. Now, alternatively, this information could be seen as more difficult to integrate into the decision process, leading to the perception of that extra information as being slightly less useful, as well, it won't be integrated as successfully, so maybe it's not worth me choosing to pay to view it. So we constructed a follow-up to test between these two. And specifically, we wanted to test, well, are they actually more confident once they've seen this reliably incorrect information? So we, again, used pretty much the same paradigm, but this time there was no auction for an extra piece of information. We just immediately asked them at the end of these 6 sources to predict which of the 2 colors would win the lottery. And after this, we asked them to estimate or to provide a confidence rating for this estimate on a continuous scale from 0 being not confident at all to 100 being extremely confident. And we did this for both the control condition and our inverted condition with the reliably incorrect information. All right, so the first thing to check is, well, do we replicate the effect of choice behavior that we saw in the first study? And we do. So here we see that choice behavior is more accurate in the control condition than it was in the experimental inverted condition. So that's good to see. Onto the slightly more interesting results, which are the confidence ratings. We found that on average, participants tended to rate their confidence higher in the control condition, which is contrary to this overconfidence hypothesis. What we see instead in the inverted condition is that increasing the percentage difference between the sets of predictors, so increasing the difference between the predictors predicting orange versus the predictors predicting pink, increasing that cumulative percentage difference only led to very small increases in confidence in the inverted condition relative to these big jumps that we see in the control condition, which is perhaps indicative of the perceived difficulty in integrating information in this inverted condition. So just to quickly summarize that, we saw that choice accuracy was again lower in the presence of reliably incorrect information, but also that confidence ratings were similarly lower in our inverted condition compared to our control condition, which is contrary to the overconfidence hypothesis that I outlined. And this indicates that the decrease in informational appetite in experiment 1 that we observed was not because participants were overestimating their ability to choose the correct color. All right, so where to for this line of research? Well, of course, this effect was observed in a controlled lab experiment that was sort of designed to mimic the broad mechanics of a real-world scenario, but of course lacks some of the nuances of a naturalistic setting. So one potential future avenue would be to bring this into a naturalistic setting. One difference in naturalistic settings is that we often construct implicit reliabilities for information based on something like the track record of an information source as we understand it, or the relative rankings in search engine results. So we might ask, for example, does this also affect behavior in the absence of these explicit reliability ratings? And is it still found when we're relying on our implicit reliability scores? And finally, we may also be interested in asking, well, how do we actually alleviate this effect? How do we either make reliably incorrect information more intuitive to understand, or otherwise, how do we promote curiosity in situations of heightened uncertainty and confusion? All right, that's everything. So I just want to end by thanking my supervisors up the top and collaborators on these projects down the bottom. This is where you can find me online. And if you're interested in the first study, that's in press at the moment, but a preprint is available online. Thanks very much for listening.
Yeah, thank you. Great, we have a little less than 10 minutes, well, 10 minutes for questions and discussions. So anyone with a question, please raise your hand, Zoom, or just speak up here. Yes, Simon.
A very quick question. I'm interested very much in the references from your slide number 36, which is about people incorporating irrelevant information. You've got a couple of references at the bottom, but you haven't given us the full reference, just the names and dates. Would you be able to give those to us?
Sorry, I was muted. Yes, I can do that. I will find them and I can email them to you, I guess.
That would be great.
This one
Thank you.
is not published, the recent one, so that should say in prep, but these two are obviously.
Brilliant, thank you.
I'll make sure.
Thanks, Almog.
Yeah, I'll send it to Simon. I wanted to ask something about the first part of the of your presentation about information hedonism, which I found very interesting. And I think that in a sense you're looking at well, if to take this to intergroup relations, you're looking at some kind of in-group favorism, right? Some kind of in-group love. And
Yeah.
I was wondering if you have any plans or any thoughts about how to incorporate this to basically outgroup hate and not just in love, right? Because I can imagine an experiment in similar settings in which you're not looking for positive information about yourself, but negative information about the other. And I was wondering if you have any predictions, whether you see a mirror image or any thoughts on this.
Yeah, no, that's a great question. And I think it's an important one to address as well, because here what we've really done is boiled down something quite complicated, this idea of informational hedonism, into something very specific, which is, this is telling me something that is positive for me. This is telling me I won 15 cents, whatever. Whereas in the real world, where the ways in which we derive hedonism from information is a lot more complicated. And it's often not from things that are necessarily telling us positive things. So for example, as you've outlined, sometimes hearing bad things about other people or an outgroup, that can give us that sense of hedonism. A lot of conspiracy theories, for example, are very unpleasant, but people like to hear them, I think, for a number of reasons, but one of them being that it affirms that you're a part of a special group that has some secret knowledge. And the more you hear about that, the more it affirms that belief. So in the real world, the ways in which we're deriving this hedonic value from information is very complicated. And here we've boiled it down to something very small and specific. So I think when we're thinking about these sorts of results and the reasons for people seeking information, it's quite important that we bear that in mind, the fact that in the real world, this behavior is much more complicated and pervasive in different ways than just the way that we're looking at it in these lab settings.
Any comments or questions?
Yeah, I do have a question. Thanks. That was very interesting. I'm still processing it. I'm not sure I fully understood it. And so let me ask a question for clarification. You showed us that the irrelevant, unreliable information didn't affect their judgment, and you did that by comparing the dominant and non-dominant. The result for the dominant and that one precisely. Mm-hmm. And yet you said that having this thing there, which they demonstrably ignored, lowered their accuracy. And so explain that to me. How can you have both of these effects present at the same time?
Yeah, it's a good question. I guess what this essentially tells us is that, yes, they are ignoring it. But if you imagine, for example, that the process of ignoring it makes you partially forget some of the other information that you've accrued, and say that information that you forgot is random on every trial, that would predict the outcome that we saw, which is that on average, across all these trials, well, you tend to be slightly less accurate because there's cognitive load involved in the process of ignoring that information, and therefore you're losing some of the information that you've already gained, and that would make you less accurate on average. Yeah, that's one possible explanation for it.
And you do this equally regardless of whether it's the dominant or non-dominant.
Seemingly, yes.
Right. Okay. I think I got that. Yes. Thank you.
Okay.
Any other?
Yeah, we have another minute or so for more comments or questions, if there's any. Yeah, Dawn.
I mean, I'll probably go ahead because I'm kind of struggling in my head to try and frame this question, but I was intrigued by what you said about people's preferences or how they're judging the source that's either providing a positive estimate or a non-accurate one. And I wondered if you sort of considered asking them how they feel or just directly their perception of these psychics. And I couldn't remember if they did find out their own lottery wins in the end.
Yeah, it's a good question. So no, they didn't find out the actual outcomes. So they didn't get to see whether or not they had actually won. They only got to see these predictions. And I think it would have been nice if we could have fit into the paradigm a question to say, well, how do you now feel? Because of course, this what we're saying about this hedonic value is at the end of the day still somewhat of an assumption. It's supported by theory and it's backed up by other results. But at the end of the day, we can't necessarily say that they're doing this because it makes them feel good, because we haven't measured how it makes them feel. So that is an assumption at the end of the day. And I think it would be nice if we could have fit that into the paradigm, but doing so would have blown out the time a little bit and made it a little bit unruly to run.
And I think like the other point I was trying to wrap in there was the sort of people judge differently if you get it wrong. Sort of think about it as an estimation task. If you overestimate and get it wrong versus underestimate and get it wrong, there's research that shows that the judgment placed on the person who's either overestimate or underestimate it is different. So I was trying to, I think what I'm still struggling with was trying to make that relevant in a question, if you see what I mean.
Yeah, no, agreed. I mean, that's
looking into.
That's partially, that's partially what we were trying to look at with the follow-up experiment, because that was an alternative explanation, that idea that maybe we weight predictions differently. So maybe predicting a good outcome and being correct during the example lotteries, that's seen as much better than predicting a bad outcome and being correct is seen as good. We wanted to look at whether that made participants see the psychics as more trustworthy than, yeah, if they were predicting the bad outcomes correctly. But yeah, we didn't find that when we looked at those results.
Thank you.
We have time for another question.
Yeah.
One question about the psychic experiment that I'm trying to see to what extent that matches the real world sort of Biden prediction thing. One of the possibilities, I guess, in the real world is that the optimism or wishful thinking, whatever you want to call it, that you observe with partisans isn't what makes them choose a news source, but is the result of them having watched that news source for different reasons. So if I watch Fox News all day anyway, then it's not surprising that I will come up with that particular distribution. And if, you know, and I then no longer choose for hedonism, but because I, you know, my false belief is a consequence of my earlier choice. And to what extent is that captured in your first experiment, that sort of possible causal link? I didn't detect that in there, or was it in there in the first 5 trials? I'm not sure if they were sufficient.
That wasn't in there, and that's going back to the sort of opening explanation. What you've explained is what I was essentially trying to get at with this idea of the Bayesian rationalism. If you have prior beliefs through, you know, watching the candidates or through having watched Fox News, and you see all this glowing reporting about Donald Trump, for example, you think, well, he's great and he's likable, he seems great, he seems very competent, and therefore he's more likely to succeed. And I'll view him positively, and I'll see news sources that say positive things about him as more accurate, right? Mm-hmm. Which is definitely a dominant factor in why we choose between different information sources. And I think it's been quite dominant in the narrative about why we choose between information sources. And this idea of informational hedonism was something that it's sort of old-fashioned at this point. People, I think we understand that people aren't just these biased boxes that want to be told this is correct and that makes us feel good. If it doesn't align with what we see in reality, we're not going to believe it, even if it makes us feel good. So what we really wanted to address in this study is, well, is this a factor at all? Are we actually biased towards this positive information in the sense that we used to think about it? Or is this all just captured by this Bayesian rationalism, and we are just looking for what we see as the most accurate information? So I guess to answer your question, no, this idea was not captured in the experiment by design more than anything. But we really wanted to focus in on this secondary idea and see, well, is this actually making a contribution?
Thanks.
Yeah, Matthew, thank you so much for
Yeah.
your time and for from this time of day, night, and so I'll stop the recording right now, and